Have you ever wondered what the future holds for our solar system in a billion years? Ponder the immense span of time that lies ahead. A billion years into the future. Overwhelming, isn't it? But that's precisely our journey today. Currently, solar system is an active part of the vast cosmos. We have the sun, our system's powerhouse, a radiant furnace supplying warmth and light. The planets, each distinct, orbit in an elegant dance around the sun. Mercury, the tiniest planet, is closest to the sun, followed by Venus, Earth and Mars. Beyond Mars lies the asteroid belt, a cluster of rocky remnants from our solar system's inception. Then we encounter the gas giants, Jupiter and Saturn, ice giants, Uranus and Neptune, and the dwarf planets, including Pluto. Each celestial body, from the largest planet to the tiniest asteroid, has its own tale and unique role in our solar system's cosmic dance. In the boundless space, and its family of planets, moons, asteroids and comets journey together, bound by gravity's unseen ties. This astronomical dance has continued for over 4.5 billion years, showcasing the cosmos' enduring dynamism. But what about a billion years from now? Will the planets still be dancing their cosmic ballet around the sun? Will the asteroid belt still be a band of rocky remnants from the solar system's dawn? Will the sun still be our cosmic neighborhood's glowing heart? The future is a mystery, teeming with possibilities and uncertainties. However, science and our understanding of the cosmos enable us to make educated guesses about our solar system's future. Now let's venture into the future and envisage what our solar system might look like in a billion years. First, let's focus on the heart of our solar system, the sun, a dazzling celestial body that holds immense power and influence. Often referred to as a blazing ball of gas, it is our world's primary source of light and warmth, an essential factor that makes life on Earth possible. The sun is a remarkable and complex entity, possessing a dynamic nature that goes beyond our everyday experience. It's interesting to note that the sun, much like everything else in the universe, is subject to the course of time and will undergo a dramatic transformation in about 5 billion years. The sun, like all stars, has a life cycle, which is often divided into several phases. Currently, our sun is in its main sequence phase, a period of relative stability where it continuously burns hydrogen into helium in its core. This ongoing process, scientifically known as nuclear fusion, provides the energy that powers the sun and allows it to shine brightly in our sky. However, this stable stage of nuclear fusion and light emission is not everlasting. In roughly 5 billion years, the sun's core will exhaust its hydrogen supply. As a result, the core will start to contract under its own gravity, causing the outer layers of the sun to expand significantly. This crucial transition is when the sun will enter the next phase of its life cycle, transforming into a red giant. As a red giant, the sun will experience a dramatic change in its physical size. It will grow so large that it will likely swallow the inner planets, including Mercury, Venus, and even our home planet, Earth. Despite this terrifying prospect, the sun's expansion phase won't last indefinitely. The red giant stage is merely a transient phase in the star's life cycle. After a few million years living as a red giant, the sun will begin to shed its outer layers. These layers, now superfluous to the sun, will drift off into space, creating a stunning cloud of gas and dust known as a planetary nebula. This nebula is not just beautiful, but also acts as a cosmic recycling bin, providing materials for new stars and planets to form. Following the shedding of its outer layers, the remaining part of the sun will be its hot, dense core, now transformed into a white dwarf. This compact hot core will gradually cool over billions of years. The once blazing sun will fade to a faint white glow, signaling the end of its time as the primary light and heat source in our solar system. The transformation of our sun from a main sequence star to a red giant and eventually a white dwarf will drastically change the face of our solar system. Entire planets will disappear, orbits will be disrupted, and new celestial bodies will be born from the sun's discarded layers. As we can see, the sun's transformation will drastically reshape our solar system. Next, we journey to the planets orbiting our sun, their future interwoven with the sun's fate. As our sun advances into its course of transformation, the planets held within its gravitational force will meet their unique outcomes. We commence with the inner planets, Mercury, Venus, Earth, and Mars. These celestial bodies, predominantly composed of rock, have maintained their proximity to the sun for eons. In due course, as the sun grows into a red giant, the excessive heat and gravitational pull might prove to be unbearable for these planets. They may either be consumed entirely by the sun or reduced to ashes, leaving behind nothing but charred remnants of what they once were. Earth, the birthplace of all known life, could possibly encounter this incandescent demise, serving as a poignant reminder of the impermanence of existence. What about the gas giants? Jupiter, Saturn, Uranus, and Neptune. These outer, nestled in the chilling depths of our solar system, might experience a different fate. The sun's expansion could displace these planets further into the solar system, consequently altering their orbits. As their icy dominions come under the influence of the sun's dying light, these planets might go through radical alterations, their atmospheres and moons reshaped by the increased heat and radiation. In the shadow of this apocalyptic scenario, there's the possibility of rebirth. Yes, even in the face of such devastation, the universe's tendency for creation could endure. The remnants of the inner planets, dispersed by the sun's death agony, could merge to form new planetary bodies. Maybe, in the far-off future, new terrestrial worlds could emerge, akin to phoenixes from the remnants of the old. In essence, it's a narrative of devastation and creation, of conclusions and fresh starts. A testament to the cyclical pattern of the planet's fate will play a crucial role in this remarkable transformation. But what about other celestial bodies? Now, let's turn our attention to the asteroids, comets, and other celestial bodies that inhabit our solar system. The asteroid belt, that captivating ring found between Mars and Jupiter, is an intriguing region that has captured the fascination of astronomers and researchers alike. It's a tumultuous part of our solar system, filled with rocky bodies, each carrying its unique journey and story. As the eons pass, the solar system will evolve in ways unpredictable to us. 1 billion years from now, when our sun expands and the planets shift into new orbits, the asteroid belt may undergo significant changes. The gravitational influence from the migrating planets might disperse the asteroids, propelling them on unfamiliar trajectories. Some of these wandering asteroids may collide with planets, creating a spectacular cosmic event. Others might find themselves escaping the gravitational bounds of the solar system, embarking on a journey into the vast expanse of interstellar space. Next, we have the Kuiper Belt, the cosmic realm of icy bodies, including Pluto. The expansion of the sun's outer layers might result in a dramatic transformation of this belt. The incoming heat could lead to the evaporation of the icy bodies, forming a new belt composed of gas and dust particles. Alternatively, the sun's heightened gravity could draw these icy bodies inward, culminating in breathtaking collisions. Further into the outskirts of our solar system, we encounter the Oort cloud. This sphere of icy bodies encapsulates our solar system, so distant that the sun's metamorphosis might not significantly impact it. However, as the planets shift and move, they could generate gravitational waves that disrupt the Oort cloud, potentially causing a comet shower headed for the inner solar system or sending them hurtling towards interstellar space. The shift in the sun's mass as it shrinks and loses its gravitational strength might allow more interstellar objects to enter the solar system, adding fresh participants to the cosmic ballet. The turbulence caused by the sun's transformation and the shifting planets could trigger the creation of new celestial bodies. Asteroids might crash into each other, giving birth to new dwarf planets, or comets from the Oort cloud might find their way into the inner solar system, becoming spectacles for future generations. These celestial bodies, often overlooked, will play their own part in the evolving solar system. We've journeyed far into the future, exploring the possible fate of our solar system. Introducing a time machine ride, 1 billion years from now, we've peered into a future that's both captivating and daunting. Let's take a brief pause to deliberate on our voyage. We initiated our exploration with the sun's transformation. The comforting star of today, a crucial component for life, will undergo drastic metamorphosis. It will transition into a red giant, possibly swallowing Mercury, Venus, and even Earth. This isn't the sun's final stage. It will discard its outer layers, forming a ghostly nebula and ultimately diminish into a dwarf, a dim memory of its former self. Next, we focused on the planets. The inner planets, if they prevail through the sun's red giant stage, will become desolate, whereas the outer planets will witness orbital changes due to the sun's mass reduction. The gas giants, Jupiter, Saturn, Uranus, and Neptune, may be propelled into new tracks around their diminished sun, propelled into the chilling expanse of space. We then wandered off to the remote parts of our solar system where various celestial bodies dwell. The asteroid belt, Kuiper belt, and Oort cloud will also be influenced by the sun's transformation. Their icy inhabitants may dissolve or be flung into new orbits, leading to a cosmic dance of drifting bodies. The future we've presented is based on our current comprehension of astronomy and physics. However, science, mirroring the universe, is ever-changing, and fresh findings might modify our forecasts. Our solar system, a billion years from now, might be considerably transformed, but one thing is certain: the universe continues to be a fascinating place, full of mysteries waiting to be discovered.